Hey folks, how's it going? Coming on here to actually do a pretty big announcement. I'll get right to it. I'm not going to waste any time. Essentially, I since the 31st of January, I had made an original TikTok video saying that I had solved the Riemann hypothesis. I know it's pronounced that way, uh, but anyway, uh, and since then it's currently the third month of the year, so March the 7th. It's been officially a little over 2 months, right? And people were like, "Where have you been?" I got rid of my previous TikTok account because I wanted to sort of quiet things down and just focus on the math and the implications that I was applying. And since then, I've been really busy, like expanding and improving my mathematical frameworks, and the results have been astronomical. For obvious reasons, I'm keeping everything pretty quiet on just the frameworks themselves because it's pretty powerful. And I wanted to have a sort of like centralized focus on how I was going to carry out my use of it and how to apply it, which is um, pretty universal. And the route I thought would be most important was quantum computing and AI, just at the current climate right now. I know that Microsoft, funnily enough, came out with a video like maybe a week or two ago, pretty recently, about the Majorana 1, which is essentially them trying to reach 1 million qubits with this new, basically like a topological approach in the fundamental design, which is like supposedly like a new element, if they want to call it that. It's not certainly an element as much as it is like I guess a method. I'm not taking anything away from it, but I'm just saying about how it was perceived, right? It's really interesting, and I'm sure they put a lot of effort into that. My approach is fundamentally completely different, and I just come out here to say that I've actually achieved 1 million qubits. Um, I've been sitting on it for a little while because I was trying to think about the best way to approach this, and I think just going out to the public and reaching out to individuals in this way is probably the best method of achieving this and getting the right people in style, yeah, not in style, but in front of this. Pretty raw video here, just from my room in my apartment. Um, I'm just queuing up. I'm gonna prove that I did it by running a live test, um, showing the math. So you can't fake it, obviously, because even if with some sort of simulated Python code, you'd have to have the formulas that achieve the results uh, in the quantum structure of it, which you wouldn't be able to do. Even if you try to simulate 1 million qubits, you would have some pretty unstable distributions, and it just would not come out about correctly. I'm not going to do too much talking. I just want to paint what I'm doing this for, how I'm going about this, and then pretty quick video here, just going to show the test itself to prove that I did it, and sort of go from there. So basically, I'm at this stage where I was trying to decide how I best wanted to go about this, but I feel like it's a pretty sought after thing, and it's best to just kind of put it in the right hands to be implemented, and then I can go from there. And more or less, essentially how I'm going to do this is that I'm going to show the test. I'll put the email, you can reach out to me. For the big players, the people in tech, the companies that are ready to do this, I can either do a few different ways of going about licensing the framework. I'm not going to sell my math, or not sell my math, but I'm not going to sell what's behind the framework. I'm not going to reveal even what the math is, not yet. I'm not going to reveal the code and the stuff I'm using. I'm going to license the framework to the important individuals that are ready to play. I'm not really going about this in a elongated fashion. I've already had some interest from certain individuals that I spoke with, but I don't want to sit on this and drag it out. There's a lot of good things that can come from this tech. So I straight to the point. Before March is over of 2025, I want to have already made some moves. So I'm only working with a small amount of individuals or and entities essentially that I'm going to be licensing this framework out to. Keeping it simple. You know, just email me. I'll provide a list of the things that I want you guys to include in the email, so that you can sift through people who are just trying to don't really have an agenda, but we want to have focus on the real individuals who need to implement this, and obviously a use case. When you email me, it'll prompt you with the information as to what exactly you need to send with it. Sorry. Anyway, so as you're going to see, it's not just me achieving 1 million qubits. It's the hardware is the original approach. They were trying to use the hardware and essentially just adding GPUs, but it wasn't necessarily making it faster, and it was also taking a lot of energy. I think the max is like around 1,000 qubits for most companies like Microsoft, IBM, and obviously I've achieved 1 million. And the method is purely lying in the framework of the math itself. So you don't need any special hardware. It doesn't require really any energy. It's basically near zero energy cost, which I know is also going to be a big thing that entities would need to rely on. There's zero computational drift, so full stability is as it expands, which I know right now a lot of times it can reach maybe higher numbers, but they're not very stable. Complete sustainability, and achieves exactly what you want to do. The biggest kicker here is the timing. I've been able to reduce the time because that's the biggest factor, right? It takes decades to get to higher qubits. I've been able to achieve it within 75 picoseconds per qubit, which in a full second, which a picosecond is a trillionth of a second. So essentially 75,000 nanoseconds to achieve 1 million qubits, and in a full second it's like they're close to 14 billion qubits that can be achieved in a full second. But I don't see why we would ever need that many qubits, and getting that high would require more reduction on the math to make sure that it looks stable at that level. But overall, these are unbelievable results. Anyway, I'll get to it because I know I've been talking for like at least a few minutes now. And I'll show you what I'm going to do is I'm going to show you guys in my notebook here, my Jupyter notebook, the test, and I've already ran the test so I can hide the code. I'm just going to rerun the kernel, and you'll see the math, not the math, but you'll see the test here in real time, so you know it's not like simulated. You can't fake this data. Let's see here. Okay, can you guys see this okay? So I'm going to run the kernel. There you go. 1 million qubits. Expected computation time 75,000 nanoseconds. Obviously complete stable. Verification complete. No computational drift detected. Stability confirmed. Total energy usage 0.000045. You know, basically zero, approach to zero. Quantum fluctuation sustained computation with no external energy input. You can see the stability here. Test complete. Oh, you guys can't see that actually. Can I move this? Actually, no. Okay. Can I move? I'm gonna arrange this a little bit so you guys can see. There you go. So you can see the writing here. But yeah, as you can see here, okay, the test complete. 1 million qubits sustained. 0 point, approach to zero basically. Computation output none. No drift. Stable. You can see the timing here as well. So this is proof, because you can't take a code really. As far as my knowledge, and I'm not like a professional coder. in the top echelon. I'm not claiming to be. I'm just saying like I have enough to do this and other things. And this is what my math has achieved. The frameworks are solid. I've worked pretty hard on them, and this and more. You know what I mean? So yeah. Basically, I'll put my email below, and obviously I'm going to be vetting for people who are serious, and I don't really have a lot of time in the sense of to go through a bajillion texts. But yeah, well, it's pretty cool. It's a pretty big leap in this space of many different things. So yeah, we'll carry on from here. I'm not going to talk much more. Reach out. Thanks.